Welcome back to NCRT class 9th chapter number 2 is matter around us pure. Children, in the previous class we studied about pure substance means what, mixture means what, and what are its types we came to know. In today's class, children, we will come with the next topic of this chapter, that is called solution. Here we are learning solution definition, examples, and the components of a solutions and the properties and concentration of a solution. These are what different subtopics related to a solution, you can say. So how can we define a solution here? A solution is a homogeneous mixture of two or more substance. If a homogeneous mixture contains two or more than that of a substances, then it is said to be a what? Solution. A solution is a homogeneous mixture of two or more substances. Isn't it, children? What is this homogeneous mixture of a two or more substances, children? Okay, let us understand by taking a example. Let us take a lemonade, children. Lemonade is nothing but that is sharbat. In our language, we will call it as a what? Nimbu ka pani, or sharbat is generally called as a what here? Lemonade. What it contains, children? In order to prepare lemonade, we are mixing sugar, we are adding water, then ilachi powder we will take, and the main ingredient what? Lemon juice we will add. Means here, when you lick it into the ingredients which are needed to prepare lemonade, here it contains many substances like sugar, it is a one substance, water another substance, ilachi powder is one more other substance, lemon juice is also what? Different substances. These all different substances, when you combine, then you will get a thing that is called as a lemonade. Means here it is a homogeneous mixture. Means all these things are going to be mixed uniformly in the mixture. Then it is a what? Homogeneous mixture. It consists more than many substances. Two or more substances will be present. Here see, four ingredients are present. Four substances are present here. So now this lemonade or salt water, salt solution, you can say it as a what? Solution. That is salt plus water. Nothing but a salt solution. Isn't it, children? Then aerated drinks also. These are all what here? Solution. And solutions also come across in three different states of matter. That is, in the form of a solid solution you will get, and in the form of a liquid solutions, and even in the form of gases. Generally, that is solid solutions in the form of alloys you will get, and many of them will be in a liquid form, nothing but a liquid solution, here lemonade. Then gaseous means aerated, here we will use a soda, isn't it, children? That is carbon dioxide gas, it is in the form of a gaseous, that is air, so it is also what? That is gaseous solution. And here that is solid solution, and the alloys we are discussing here, children. I want to give a brief information of this alloy. You know, children, alloys are the mixture of two or more metals or a metal with a non-metal, and the composition will be what? Different here, children. Isn't it, children? It will gives the different composition. So means the physical properties will be what here? Different. And the alloys will be formed by using a what? Two or more metals, or by using a metal with a non-metal. The best example is, children, brass. Brass is a kind of a alloy. Example, it is a what? Alloy. It is formed by using 30% zinc, then nearly 70% copper. Isn't it? When you combine this zinc and copper, you will get a alloy which is called what? Brass. Is it clear, children? Solution is nothing but it's a homogeneous mixture, uniform composition. It consists of more than two substances in it, and sugar solution, salt solution, aerated drinks, then solid solutions, liquid solution, gaseous solutions. These are what? Different types of a solution. And the main thing I want to say here, a solution will contain two components. How many components will be present, children? Two components. One is solute, the second one is what here? Solvent. Children, solution contains solvent and solute as its main components. Means a solution will consist of two main components. What is that? Solvent and a solute. What is this solvent? A solvent is that is substance which is going to dissolve the another component. It is a type of a component, isn't it, children? It is a component of a solution. It is going to dissolve the another, that is other component is going to dissolve in this solvent. Then what is this solute? A solid is also a kind or a component of a solution which is going to dissolve in the solvent. Understanding, children? Okay, let us take a example, no problem. That is here, let us take sugar plus water. Isn't it? This sugar is what here? Solid. What is the state of the sugar here? Solid. Then water, it is a liquid. A component of a solution which is dissolving other component. Isn't it, children? In this liquid, sugar is going to dissolve. Then now the liquid is called as a solvent. Whereas the component which is going to dissolve in the solvent is called as a solid. Which is a solid here now? What? Obviously what? Sugar. So how can we write the definition, children? A solute, a solvent is a one, or it is a component of a solution. You can write solvent is a one which is dissolving other component in it, and also its quantity will be more, children. Its quantity will be more. Here the water content will be more, no? Yes, compared to the sugar, water is more. So obviously what here is solvent quantity will be more. Then how can you write the solute definition? A solute is a another component of solution which is dissolving in solvent. Isn't it, children? And here its quantity will be less. Quantity will be less. Isn't it, children? Is it clear now? Let us take few more examples. That is example number 2. Isn't it, children? Salt solution or sugar solution. In that, sugar or salt will become a solute, and the water is over here solvent. And let us take that is tincture of iodine. Tincture of, commonly called as a tincture of iodine. Here iodine is a solute, whereas tincture nothing but a alcohol, children. Is a word here liquid. Nothing but a alcohol is a word here solvent. Iodine is a solute. Is what solute, especially what carbon dioxide gas, then water, which is nothing but a liquid. And you can take one more, children, that is what air. Example 4, you can take air. It consists of different gases. Many gases will be present. It will contains oxygen, nitrogen, isn't it? Nearly 30%, that is 21% of oxygen will be present in the atmosphere, and 78% of nitrogen is going to be present. Along with that, a negligible amount of other gases is also present in our surroundings. So these are what a few examples of a solution. Means a solution contains what solvent and a solute as a main components. So what is mean here? These two different components will give rise to a solution. Now we will discuss the properties of a solution. Now we will discuss the properties of solution. The first property says that, children, it is a homogeneous mixture. Solution is a homogeneous mixture, and the size of the particles will lie smaller than 1 nanometer. You know, children, 1 nanometer is equals to 10 to the power of minus 9 meter. That is what? Diameter. Diameter of a particle is what? Very, very small. So we can't see these particles through our naked eyes. Cannot be seen through our naked eyes, because they are very small in size. That is how much, right? 1 nanometer, nothing but a 10 to the power of minus 9 meter in diameter. Means the particle's diameter is what? Very small in size. And because of this smaller in size, the path of the light is not going to be visible. Scattering of a light is not occurring. Scattering of light is not occurring due to small in size. Due to smaller in size. The particles of the solution are what? Very small in size, and hence the path of the light is not visible. So children, in the activity 1, first group A and group B, why the path of the light is not visible? Means because those two formed into a solution. Means the particles are very smaller in size, and hence in those two, that is group A and group B, are formed into a solution. Hence, path of the light is not visible in the solutions. And the third property says that is when you left them, that is undisturbed for some time, they are not going to settle down. Means we are not going to separate the particles in the filtration method. We cannot separate the particles by filtration method, or even they are not settling down, means they are stable. Understand, children, what are the main properties of a solution? They are a homogeneous mixture and the size of these particles are very small, and it lies in the range 10 to the power of minus 9 meter in diameter, and because of such a smaller in size, we can't see through them, that is with our eyes, and also the path of the light is not going to visible in a solution, and these particles are stable, means they are not going to settle down if we undisturb the substance. Is it clear, children? Children, after learning the properties, then examples, and what is the definition of a solution, now we will discuss concentration of solution. What is that, children? Concentration of solution. So, do you know the meaning of a concentration here? Means here the amount, you can say in general term. So, in the chemistry, for a given different types of a solution, the amount of or the quantity of a solute or solvent may be different. Means their proportion going to be vary. So, in such a case, depending upon the differ in amount of a solute and a solvent, we have different types of solutions. It might be a dilute solution or concentrated solution or a saturated or a unsaturated solution. So now we are going to discuss these different types of a solution based upon the amount of a solute or solvent present in a given solution. So, first here, let us discuss, that is about dilute solution. What is that, children? Dilute solution. We know a solution will contains mainly two components. What are those, children? Yes, solute and a solvent. Suppose in a dilute solution, means actually the meaning of a dilute solution is if amount of a solute present less than that of a solvent, then it is called as a dilute solution. Once again, I will repeat, children. The quantity or the amount of a solute is going to be less compared to that of a solvent for any solution. Then such a solution is called as a dilute solution. For example, that is, I'll write now first definition, children. That is, if amount of solute present in a solution is less than the solvent, then it is called what? It is called dilute solution. Isn't it, children? Okay, now concentrated solution means what? concentrated solution. For example, see children, here the amount of a solute is more compared to that of a solvent in case of a concentrated solution. That is, solute is more than solvent. Then it is called what? Concentrated solution. But let us imagine this is the test tube. We will name it as the first test tube 1. Our test tube name, it is what? 1. We will fill half of the test tube with the water. Nothing but here H2O. What is this? H2O. It has contained how much quantity, children? Half of the test tube is what now? Filled with the water. Suppose if we add, that is HCl, few drops. Isn't it? What we are adding? We are adding HCl. Nothing but here this HCl quantity is how much now? Only few. Only little amount of HCl. Nothing but a solute here. This HCl is now what here? Solute. If we added, that is in a water, that is water, nothing but here solvent, which contained it what? More in amount. Whereas solute is what here? Very, very less. Isn't it? So the huge amount water is now called as a solvent, and here this is what? HCl is now solute. If this solute is present less than that of a solvent, then it is called as a what here? Dilute solution. What is this now? Dilute HCl solution. Suppose for the same test tube, if we take, that is a more amount of a HCl, if we add nearly 5 ml of or 2 ml of HCl, this is what? 2 ml of HCl we are adding. Suppose if we add only a few drops of water, means what became here? The amount of water is now less, because it is now only few drops of water we are adding. That is few drops of water. This solvent is now what? Less, but solute is what here? More. Then such a thing we will call it what here? Concentrated solution. If the amount of a solute is more than that of a solvent, then it is called what? Concentrated solution. Understand, children? Dilute means solvent amount will be more, whereas solute will be less. Whereas concentrated means solute will be more, solvent will be less in amount. So these are what? A dilute solution and a concentrated solution. Now we will discuss what is mean by saturated solution. Now we are discussing what, children? Saturated solution. Means for a given or for particular temperature, if the amount of a solid is not going to dissolve in that. Understanding, children, my point? At one particular temperature, if the amount, that is if we add solute to that solution, if it doesn't dissolve, means then we will call it as a saturated solution. Let me explain with an example, children. Let us take a that is beaker which is filled with 50 ml of water. Isn't it, children? Now if we add salt or sugar or sodium chloride to this, after stirring it well, if we heat this beaker, test tube, nearly, that is by raising the temperature by 5 degrees Celsius, At one fine temperature, if we add once again, that is solute, some more amount of a solid if we add it to this test tube, means it is not going to dissolve. Before heating, at one fine temperature, the salt, that nothing but a solid, is going to dissolve. But at one particular temperature, once again if we add the solid, it is not going to dissolve. Then it is called as a saturated solution. And here the amount of a solid which is going to dissolve in a saturated solution, it is called as a solubility. What is the meaning of a saturated solution, children? That is, if any particular temperature if any particular temperature, the amount of solute that is not dissolving in a solution, then it is called what? Then it is called saturated solution. In other words, simply we can say that at one particular temperature, if the amount of a solid is not going to dissolve in a given solvent for any kind of a solution, then we will call it as a saturated solution. Suppose if the amount of a solute is present less than that of a saturation level, then it is called as a unsaturated solution. How we will define unsaturated solution, children? For a given temperature, the amount of solute is less than the saturation level then it is called unsaturated solution. Understanding, children, the concept saturated and unsaturated solution? If the amount of a solid is less than that of a saturation level for a given solution, then it is called as a unsaturated solution. It means that here one thing we have to clear, children, depending upon the amount of a solute present in a solution or solvent, then we have different types of a solution here. So generally the concentration of a solution can be expressed three different ways. That is, by concentration of a solution is nothing but a here, that is amount of a solute divided by amount of a solvent into what? 100. Nothing but a here the percentage, how we are going to calculate the concentration of a solution. Any solution, if we want to know its concentration, then we have to use these expressions. Okay. So children, concentration of a solution is equals to amount of solute divided by amount of solvent. Isn't it, children? Or you can take their solution also, no problem. And how we will express, children? That is mass by mass percentage which is equals to mass of solute divided by mass of solvent into 100 we have to use. Suppose if you, while solving the problems, if they asked us to calculate sorry, the mass by mass percentage using this expression, calculate the mass of a solute, so and so solute means, then you had to use this formula. And one more formula we have, mass by volume percentage. Volume percentage. So it can be written at this time, mass of solute divided by volume of solvent. You have to take and you have to multiply it by 100. These two expressions are very, very important, children. You have to remember and also you have to learn this. Okay, now we will solve a simple problem based upon this concentration of a solution formula. Children, here is our first problem, that is a solution contains 40 grams of a common salt in 320 grams of water. Means here the solute is what here? Common salt, and the solvent is what here? Water. How much amount of a solute is there? 40 grams of a solute, whereas 320 grams of a water. Nothing but here 320 grams of what? Solvent. Now, calculate the concentration in terms of mass by mass percentage of the solution. Is it clear, children? Now the question what they asked? They asked us to calculate the concentration in terms of a mass by mass percentage. I hope you know which formula we have to use now. Yes, very good, children. We have to use now mass by mass percentage. Nothing but what is that? Mass of a solute divided by mass of a solvent into 100. First, let us take how much amount of a solute and a solvent is present in a solution, because a solution is nothing but a amount of a solute and a solvent. So first we have to take sorry, children, that is mass of solution is nothing but a mass of solute plus mass of solvent, isn't it? What is the mass of a solute, children? 40 grams. And then mass of a solvent 320 grams. So 40 plus 320, how much? 360 grams is the mass of a solution. What is that, children? This is what? Mass of solution. So now we know that. What is the formula? Mass by mass percentage is equals to mass of solute divided by mass of, what is that? Solution into, what is that? 100. So what is the mass of a solute, children? 40 G divided by nothing but grams. Solution how much is there? 360 into 100. Now if we do cancellation, this 0, what is left? 400 divided by 36. So you can do directly 36 1 and 1 or else you can go still easy method, that is 1 2 1 then 8 2 and double 0 9 10 so 100 divided by 9 9 1 9 1 isn't it, children? Once again 9 10, let us take 9 table 11.1, it will continues. So what is our answer? 11.1 percentage is the concentration what in terms of mass by mass percentage of the solution. This is one method in order to solve a concentration problems, children. Okay, children, in today's class we learn what is mean by solution, what are the properties of a solution, and also we learned different types of a solution. Dilute means what, concentrated means what, saturated, unsaturated, and different methods of expression of a concentration of a solutions we learned. Is it, children? I hope each and every concepts are clear to you. Suppose if you have got any doubts, please contact.